Today, we are doing another deep tech discussion, this time to understand the latest developments at Chilas. Based in the Netherlands, Chilas is a laser manufacturer founded in 2018 that develops and commercializes widely tunable ultra-narrow linewidth external cavity lasers. Such lasers have a wide range of applications ranging from fiber optic sensing, telecommunication, even LiDAR. Now, after 4 years of hard work and collaboration, they've announced a brand new lineup of 3 lasers: Atlas, Comet, and Polaris. Dimitri Geskus is the CTO of Chilas. Dimitri, why launch this now, and what gaps in the market are you covering?
Yes, so we launched this now because the technology is ready. It's a technology-driven product, and we rely on the silicon nitride feedback circuits. And now we put it into a nice and nifty small electronic driver. It fits into your handheld, and you can turn it on. And you don't have to worry about the technology. It's just an off-the-shelf turnkey solution in your lab.
You can do 100 nanometer tuning range with sub-kilohertz linewidth. What is the killer application for this?
I think the killer application is going to specialized applications like quantum transitions, where you don't exactly know which wavelength you have to target. Our laser can tune to your wavelength and you can lock it to your application. I think that's the strength of this technology. It's small, it's compact, so you can also fly it up into the air, into a space application, wherever you want to have your laser there.
And of course, we are talking about tuning with a very robust form factor with no mechanical tuning elements. How does it make you different from the competition?
Yeah, that's an excellent point you're mentioning there. So the classical lasers are based on a grating that's mechanically moved back and forward. There's always some lag in there. There's always some noise and vibrations in there. Our lasers rely on fully integrated circuits, so they are really robust. Yes, there is a lot of mode hops, but they're indicated, they're mapped, and they always go like clockwork. So you can really nicely map the full laser behavior and stitch all the mode of your tuning ranges and make it continuous tune to whatever wavelength you want to tune to.
How have you used photonic integrated circuits on silicon nitride and indium phosphide to enhance the performance and scalability of Chilas laser solutions? And what are your technical demands for the big foundries?
Yes, so our big demands on the big foundries are basically having robust and stable chip technology, so that when we order a chip technology, that we get a robust, similar quality coming out of the clean room. And then for the assembly, what we need is a solid assembly that can be shock-proof and is during for a long term. This is nowadays available. And I think for the future, what we're looking at, we're expanding our portfolio to have more wavelength ranges available. And there we have a heavy demand on the 3.5 semiconducting devices, where we can expand the wavelength to another application fields, like the 680 nanometers or the 850 nanometers, or even very short, the 400 nanometers. But also the long wavelength ranges are becoming now more and more interesting. So we can now tailor the silicon nitride to 1700 nanometers, and that's running proof in our lab.
Like every photonics company that puts a standalone module in the market, your key innovations are in electronics and specifically in electronic drivers. Could you give us a few hints on how these electronic drivers optimize your laser stability and tunability?
If you look at our laser, it's put into a standard 14 pence butterfly. It's a very standard form factor. However, any off-the-shelf laser driver will not work with that laser. There are 3 heaters on the laser board that have to be addressed and have to be mapped. And therefore we have the new laser driver with an onboard processor there and allowing for mapping of the full characteristics of the laser inside the driver. So that's making the electronics very important. It has been a journey of 3 years to develop this driver, to make it low noise, agile and fast, so that we can calibrate very fast, because otherwise we need to calibrate for days. This is calibrated fully automatic in our labs and runs very smooth in your lab.
Building the map, of course, is customized to each particular laser. Does it need recalibration?
So thanks to the improved quality of the chip technology, we don't see any warp over time anymore. And therefore the calibration is valid for a long time. If in the future, for example, recalibration has to be carried out, we can do it here, but we're also anticipating in the future while having onboard monitors there to recalibrate with a click on the button, and that the laser calibrates itself. That's in development, and for very, very long-term durations, like multiple years in the future, we might have to switch that on. For now, we have not seen that happily, and the laser is stable over a year.
Your new lasers cover a broad spectrum of applications, as you said, from quantum to LiDAR. On the customer side, which industries have shown the most demand for these solutions?
The biggest industries currently are the industries on sensing applications. Fibre rating sensors, where they have to hit all the responses, but also on the quantum sensing applications, where you've got a very specialized wavelength there, which you want to address and want to tune over to address your quantum clock transition or other transition there. So there are the emerging fields. Also biomedical applications, where they're moving from a lab infrastructure to handheld devices. There our laser fits perfectly.
In QKD and also, of course, on quantum key distribution, but also, of course, on optical coherence tomography and OCT, having a wavelength tunable range is very important, but even most important is having frequency stabilized lasers. I know you have made a lot of effort on having your lasers frequently stabilized. How do you think you solve an issue in the current market, both for QKD and OCT?
Yeah, so for QKD, you need a very stable laser. Yeah, the stabilized line is by far the best application there. And since you are driving these QKD engines over a telecom network, our lasers can tune with a single module. You can hit all the ITU grid wavelength transitions you want to address there. And there we have internal and external options to stabilize the laser even further to really lower the noise levels. For OCT, it's a bit of a different thing. For OCT, we've got a swept source application there, but we can also skin very fast several grids there. And there we're running on an application that we scan a grid of wavelengths and thereby map the full thing with the OCT application.
It's been 4 years of very hard work. From the very beginning, you've been talking to customers. Could you summarize the feedback received from the early adopters so far?
So we received a lot of feedback from customers that they're very happy with a very compact form factor and the performance, this narrow linewidth character of these lasers. It really opens up for them a new field of applications. Now we can also dream about applications with handheld applications. And there the new biomedical, but also quantum key distribution fields are opening up, that we've got a compact module that can be put into a bigger system, having all the wavelength agility in there and having the interface ready to be integrated into the bigger systems.
Let's talk about the next 5 years, because I think the next 5 years are going to be very exciting for the photonics industry in general, but for the tunable and swept laser sources in particular. What's your roadmap and what's the role of tunable and swept sources that are going to be taking in the market, or in your opinion, in the next 5 years?
In the next 5 years, Chilas is focusing on a natural organic growth of the company. So we're expanding the portfolio, putting more wavelengths onto the market, and we're trimming our electronics that we can customize it more easily and adapting it more easily to multiple applications there. So more compatible with what's around there. And based on that solid basis, we plan to expand our portfolio into large volume applications. And also in the future, I always see that the photonics industry right now is on a level of electronics, the integrated transistor technology in the early 60s, 70s, something around that value, where you had a few niche applications that you've had your first transistor radio on the beach turned on. A local oscillator, that's what these things made. Chilas Lasers is making a local oscillator for the photonics industry. I don't know what the applications will be, but it will be a wild range of applications. It starts off with R&D, with big industries. And then we go down to smaller industries with handheld applications. And I think Chilas format fit into the future for very big volumes. But we go for a range like Intel did, that we've got Chilas inside into an application of someone else. We have a team here that is a long experience over years in photonics, in integrated circuits, and we can help the customer right now already we're dreaming on that pathway to how to implement a light source into their applications on chip level, but also in the lab level with this turn-on solution. That's the goal what we're having right now.
You started working on 1550 because of the use of indium phosphide gain. Are there new wavelengths or product enhancements in development that maybe you can share with us?
Yes, so we currently have off the shelf 680 nanometers, 850 nanometers. 1 micron is being developed this year. O band, S, C, L, and U band. And all of that is, except for the 1 micron, is on the shelf available in our lab. And we're expanding the portfolio rapidly. New runs will open up very fast.
So you're working on 1060 nanometers on 1 micron. What application do you have in mind?
For the application field for 1060, there's also a lot of applications again. There's a lot of OCT for bladder cancer monitoring. Mainly OCT applications are popping up there. And also biomedical applications where they go deeper into the tissue. But telecommunication is also popping up. It's a historic line from the neodymium laser. So there's so wild applications going there.
And of course, the success of Chilas is a success of the philosophy of collaboration. So let me ask you the Optica question. How can the other Optica Corporate members help you? And how can you help the other Optica Corporate members?
What I need from the Optica members is a support on the technology to be bringing to the next level. On assembly side, on chip technology side, new semiconductor gain sections, new feedback circuits, and also very fast modulators. Thin film lithium niobate is now on the menu. There are some other fast modulator technology on the menu. And I think that's the stuff we need here at Chilas right now to go for the next step, to go for transceiver applications or other applications where you need fast modulation or new colors on the chip. What we can offer from Chilas is a lot of expertise on what we currently have. We know very well what we have, and we can very easily adapt it into a new application and help also other technology to improve the technology using our laser. It can be a fast modulator, there can be another technology on fast detection. It's all available. We've got full control over the full production line, and there we can help also other platforms to make the next step.
Thank you very much, Dimitri. First, of course, for using the Optica platform to find potential partners, suppliers, and customers, but also for the huge development of bringing photonic integrated circuits, solving these problems both in OCT, quantum technology as well. Chilas Lasers tuned to your wavelength. Thank you very much for that.
Thank you.